Next, let's look at the 5760. 51, a mid to low-end model. Its total speed has decreased to 5.95 Gbps, but it still supports all the necessary features, including independent radio frequency scanning, right? It also supports built-in antennas, IoT modules, Bluetooth, etc., which are characteristics of the 5760. Moving on, let's look at its hardware structure. It has the same anti-theft lock socket as others. On the side, port 2 is for GE, 3 is a USB interface, and 4 is a 5GE electrical port. Through this interface, we can power it. Previously it was 10GE, now it's down to 5GE, meaning its bandwidth has also decreased. 5 is for the DC power interface, used to connect a 48-volt power adapter. 6 is the reset button. Let's continue to look at a few more APs. The 576022W is a panel AP, with a speed of 5.37 Gbps, supporting only dual radio frequency modes, 2.4 GHz and 5 GHz, with spatial streams of 2x2 and 4x4, so the gap compared to our indoor deployment APs is significant. Looking at its interfaces, the highest is 2.5 GE divided by 2, compared to our above-mentioned mid to low-end model, also divided by 2, then 2.5 GE electrical port, 10 GE optical port, 4 GE electrical port. Because such APs are more commonly used at home, once installed at home, they are likely directly mounted. Then, through our Ethernet cable, extended to various rooms for our wired, or to connect another AP. Thus, this type of panel AP tends to lean towards home wireless router production. Our home wireless routers are generally also with multiple ports for expansion. So here as well, expanding to 4 electrical ports, it can extend into our rooms. So the biggest feature of this panel AP is the power plug panel. We can directly plug the panel AP into it. We can take a look at its back panel. Normally there should be a small protrusion here, which can be directly plugged into the power strip, combining directly with our panel. So its deployment is relatively more aesthetically pleasing. Other home APs or other APs have this type of placement installation method. So you see it supports concealed and wall mount installation methods, facilitating deployment. This is its biggest feature. This is our panel AP. It also supports smart antennas, supports USB, and what else? It can not only receive power but also supply power, can power an IP phone or an external internet module. And it also supports 3 types of management modes. Let's look at its power board. 576022W here. Port 8 is a 2.5 GE port, which we can use for PoE to power this device. It supports 2.5 G uplink. Port 5 here is an expansion port. Can connect other APs while also supporting powering devices. These ports are all for expanding to connect other APs. Let's next look at a central AP, AirEngine 9700DM. You'll find its name similar to the AC 9700M we discussed earlier. Here it just has an additional D. This device looks like a switch, or it also looks like an AC. But in fact, it is an AP, so it can't emit wireless signals by itself. It actually releases wireless signals through a remote unit RU connected to this device. So this central AP is generally placed in cable rooms or corridors. Then, through this device, it connects to some RU devices, which are the actual signal-releasing small APs. The 9700DM is a Wi-Fi 6 central AP, and currently it is only compatible with the 576022W panel AP we just discussed. If we use the 9700DM as a central AP currently, it can only be paired with the 576022W as a remote unit. Looking further at the AP, the central AP itself has a limitation, supporting a maximum of 4,096 users. It has only 24 downlink ports and 4 uplink ports. The 24 downlink ports are used to connect remote units, and it can also expand to 48 APs through the uplink ports. However, this expansion is done via a switch, so there's no need to deploy an additional central AP. Just connect the central AP directly to a switch, then to remote units, and you can expand to 48. It also supports 802.11a, B, G, N, AC, AC Wave 2, AX. As previously mentioned, the AP's suitable scenarios include hotels, dormitories, and medical facilities. Let's continue to look at the hardware structure of the 9700DM. Its front panel has 24 GE electrical ports and 4 uplink optical ports. Ports 3 and 4 include a console port and a management port. PNP is a reset port, along with a USB interface. The back panel includes power connectors, fans, and a ground wire. Now let's introduce an outdoor AP. Previously, we discussed indoor APs, including deployable, panel, and agile distributed central APs. Next, we'll introduce an outdoor AP. This outdoor AP has a total rate, which we often use, of 10.75 Gbps, similar to our indoor APs. And it supports long-range coverage mode, supporting tri-band, dual-band modes, and dual-screen plus independent scanning mode. It includes one 10 GE electrical port, one GE electrical port, and one 10 GE optical port. A major feature of outdoor APs is the added outdoor protection. It supports protection against lightning, water, and dust, and operates at a wide range of temperatures, from -40 to +65 degrees Celsius. It can also meet the high-temperature application scenarios in regions like the Middle East. And it also features built-in independent radio frequency scanning, supports Bluetooth, and supports 3 AP modes. This page shows its hardware structure. Let's take a look. Port 1 here is the PoE port, which can also power external devices. The switch connection is port 2, which provides power to the outdoor AP. The power supply for the outdoor AP must meet or exceed PoE standards. And the other ports are the same as those previously introduced, with port 7 being a feeder port. Finally, let's introduce some of Huawei's WLAN product features. First, let's look at the feature of intelligent antennas. It is an antenna array, and it's important to note that it includes multiple directional radiations and an omnidirectional radiation mode, meaning that normally an antenna is either directional or omnidirectional. But an intelligent antenna coexists with both directional and omnidirectional capabilities. Thus, there is both omnidirectional and directional antenna coverage. Advantages of intelligent antennas include a larger coverage area. Due to the more concentrated energy and higher gain of intelligent antennas, they achieve a larger coverage area. The coverage angle of an omnidirectional antenna can reach the coverage range of a normal directional antenna. Second, it has strong anti-interference capabilities. The antenna generates spatially directed beams according to the direction of useful signals and interference, aligning side lobes and nulls. It suppresses interference signals from the direction they arrive. The last advantage is minimal RF pollution. With terminals receiving the same power, the device transmits less power, thus reducing potential electromagnetic pollution to the environment. Another feature is software-defined radio. This technology, which we discussed earlier about independent radio frequency scanning mode, is related to software-defined radio. It allows for flexible switching between dual-band, tri-band, and independent frequency scanning modes. You see, in high-bandwidth scenarios, we can opt for dual-band mode, which offers greater throughput. In high-concurrency scenarios, we can use tri-band mode, as 3 frequencies can accommodate more users. However, more users on 3 frequencies will inevitably reduce the overall average bandwidth. So the choice between these 2 modes depends on whether you need higher throughput or need to accommodate more users. Additionally, if we are in a situation with a lot of interference and we want to use its tuning function, then we can choose the dual band plus independent frequency scanning mode, which demonstrates the flexibility of switching between these 3 modes. The last part, which is pretty much standard across most manufacturers, is priority for VIP users. VIP users have 2 characteristics. They are not subject to speed limits, and their data is prioritized. Let's see how it works. First, VIP users are not throttled. So once a user is marked as VIP, speed restrictions do not apply to them. However, other non-VIP users, that is, those connected under the same SSID, have limited speeds. But if you're marked as a VIP user, then your data won't be restricted by these policies. Another aspect is priority in data scheduling, meaning VIP users' data packets have higher priority. And in bandwidth contention, VIP users will naturally have higher priority. Thus, during air interface congestion, our VIP users are favored over regular users, obtaining more bandwidth resources. This chapter primarily introduced the evolution of WLAN and key technologies of Wi-Fi 6, along with Huawei's WLAN products for various scenarios, including ACs and APs, APs mainly including indoor ceiling APs, panel APs, agile distributed APs, and outdoor APs. Finally, some features of Huawei's WLAN products were introduced. In the next lesson, we will begin learning about Chapter 2 content, WLAN security and configuration. Thank you, everyone.